Hello there, and welcome back for another video. In this lesson, we're looking at customary units of measurement. I'm on page 34 of the workbook, and we may use the calculator. I see the little calculator icon, so this one is a calculator problem. They are reminding me of the units that I need to use for this lesson. So let's take a look at number 1. Laurel pours 8 fluid ounces of water in a diffuser every morning. How long will 1 gallon of water last? So I can see that the conversion I'm working with is fluid ounces and gallon. That would be capacity. So I need to convert. I'll draw that proportion that I showed you how to do in the lesson. And I want to say that she is putting in fluid ounces every morning. So 8 fluid ounces goes in every morning. Now I can't put 1 up here because it's 1 gallon. We have to do a little bit of work here. I need to get the gallon in terms of fluid ounces. So I know that 1 cup has 8 fluid ounces, and we learned that there are 16 cups in a gallon. And so 8 times 16 is 128 fluid ounces in that gallon. And then I'm ready to do my proportion. So I have 1 times 128, that is 128. And then divide by the number that's not in the peanut. So 128 divided by 8 is, use your calculator if you need it, is 16. So 1 gallon of water is good for 16 mornings, just over 2 weeks. I do that same thing every day. Okay, number 2. Fran makes 6 quarts of limeade and fills 3 small water bottles with 18 fluid ounces each. How many fluid ounces of limeade are left over? So the first thing Fran is going to do is make the 6 quarts. So let me sketch a picture for this one. I don't have a lot of room here. But let's say that this is, and I can't draw either, can I? This is her 6 quarts of limeade. So let's figure out how many ounces are in 6 quarts. Well, I know that 1 quart has 4 cups, and each of those cups is 32 ounces. So 1 quart is worth 32 ounces. So that means that 2 quarts would be worth 2 times 32, that's 64 ounces. So then let's figure out what 6 quarts would be. 6 times 32 is 192 ounces. And that's my text message feature. I'm sorry. Let me mute my phone now. So, what are we looking at? We're going to take that 192 ounces and we're going to split that up into 3 bottles. Okay. So here's a bottle. That's 18 ounces. And she has not one of those, but 3 of those. Okay, so 3 times 18. Use your calculator if you need it. It's early, so I'm going to do it. 54. So she took the 192 ounces and she took out 54 of them. Remember, it said leftover, so this makes sense to me. I think 138 ounces are left. So I am liking A on this one. If you need a picture to help you understand what's going on, use it. You don't have to draw bottles, just draw boxes or whatever you want to do. Whatever helps you with the thought process is what that scrap paper is for. The proportion up there in number 1 helps me. That's one way I use. But not everybody likes that. So whatever works for you, use it. Okay, number 3. Mark cuts, that's breaking down, so I suspect already it's either subtraction or division. Mark cuts a 7-foot board into 4-inch pieces. How many pieces does Mark have? So again, I'm going to use a picture. I'm going to take this board that Mark has that is 7 feet long. But be careful. Be very, very careful. The pieces he's cutting are not 4 feet. They're 4 inches. So when he makes a cut here, it's not this long. It is this long. He's cutting very small pieces. So I'm going to convert that 7 feet. I know that 1 foot is 12 inches. So 7 feet, that's 7 times 12, is 84 inches. So make the conversion from feet to inches. And then do the division. Then 84 inches divided by 4 inches. You always want these 2 units to be the same. Inches divided by inches. So 84 divided by 4 is 21 pieces. And that will be D. These require you to think through a series of steps. Number 4. Lee paints a mural, that's a very large picture, on a wall that measures 8 feet 9 inches long and 5 feet wide. How many inches longer, that's subtraction, is the mural than it is wide? Now don't let this one mess with your mind. Let's draw what it's saying. This is a rectangle. We have, oh my drawing is awful. And I haven't even had coffee yet. It is 8 feet 9 inches long and 5 feet wide. And longer tells me to subtract these 2 numbers. So I'm going to go ahead and do that first. You don't have to. In fact, my teachers in school taught me to do the conversion first, but I'm going to do it my way. So I have 8 feet, 9 inches, and we're going to subtract 5 feet. Now you want to make sure you put that with like units. Feet go with feet. And that leaves me with 3 feet, 9 inches. But my answers are in terms of inches. So here is the time to convert. I know that there are 12 inches in a foot, so I'm going to say 12 times 3. That's 36 inches. Plus 9 inches. Make sure you don't lose the 9. Is 45 inches. So that is going to be B. You could have done 8 times 12 and converted it from the beginning, but you would have to convert both the length and the width. So this is less math, but the other way would work just fine. Number 5. Jane has 4 feet 7 inches of ribbon. That's what she has. Jane. Debbie has 59 inches of ribbon. How much ribbon do Jane and Debbie have in all? So this is an addition problem. And I'm going to say 4 feet 7 inches plus 59 inches. That's going to be 7 plus 59 is 66 inches. And here is 4 feet. And you may be thinking, whoa, this makes no sense at all. That's not even close to my answer choices. But we have some conversion to do. This 66 inches, we're going to convert that to feet. So I'm going to draw the conversion out on this one. This one's a little bit harder to see, I think, than some of the others. But if you want to convert inches to feet, you know that there are 12 inches in 1 foot, and that we have 66 inches to work with. So you will multiply 1 times 66 and divide by 12. Now I'm going to do this division longhand, because if you do it on the calculator, actually, no, you still won't. No, you can. You can do it with your fraction feature, I believe. I don't have that calculator in front of me. So let me just quit talking and divide it for you. I'm going to say 66 divided by 12. That's going to go 5 times with 6 inches left over. So I'm going to put, let me go ahead and finish this. This is 5 feet 6 inches. So I'm going to combine these 4 feet up here with this 5 feet to get 9 feet, and then 6 inches left over. And that actually is one of my choices. That is A. So you may have to convert from smaller units to larger. You may have to convert from larger to smaller. It just depends on the problem. All right, number 6. 1 bottle contains 16 fluid ounces of grape juice. How many quarts are in 12 bottles of juice? Well, I'm going to say, let me see if I have room here. First thing I'm going to do is take 12 bottles. Let me do it this way. I'm really trying to show you how drawing a picture can help you. You don't have to draw a picture if you don't want to. But here's a bottle of juice, and it has 16 fluid ounces. We have 12 of those. So 16 times 12, get my calculator up here, 16 times 12 is 192 fluid ounces of grape juice. Now I want to convert that into quarts, and that's where I'm going to use the conversion proportion. Again, you don't have to do it this way. If you prefer not to, that's fine. So we are comparing fluid ounces. We want to turn that into quarts. Now I know that 1 quart has 4 cups, so that's 4 times 8 fluid ounces. That's 32 fluid ounces in a quart. And I need to convert 192 of those fluid ounces. So I'm going to say 192 times 1, that's 192. Don't skip that step, guys, because it won't always be a 1. Don't allow yourself to take that shortcut, or it'll get you. And then divide that by 32 to get 6 quarts. So it's the same amount of juice. 192 fluid ounces is 6 quarts of grape juice. Number 7. Bill's truck has a towing capacity of 4 tons. His camper weighs 7,245 pounds. How many pounds can Bill add to the camper without exceeding the towing capacity of the truck? So we have a truck that can handle 4 tons. And we have a camper that weighs 7,245 pounds. And when I look at my answer choices, they are in pounds. So I'm going to convert everything to pounds. So 4 tons, that equals, let me not do it there. Actually, I can put the equals, but let's do it down here. I'm going to convert my truck weight. And I like the proportion. I'm going to convert tons to pounds. And 1 ton, if you need to look back up here, that's fine. 1 ton is 2,000 pounds. And the truck is 4 tons. 4 times 2,000 is 8,000. 8,000 divided by 1 is 8,000. So the truck is 4 tons or 8,000 pounds. Those are 2 units that mean the same amount. So 8,000 pounds is the weight of the truck, or the towing capacity of the truck. I need to find the difference between those 2 numbers. So 8,000 minus the camper. And since I don't have room to do this longhand, I'm just going to do my calculator. 72.45. That's a difference of 755 pounds. So he can put 755 pounds of stuff in his camper and still be within the limits of the truck's towing capacity. Number 8. Casey plays soccer and tracks her running distance per game. In one game, Casey runs 10,560 yards. How many miles does Casey run? So this time I am converting yards into miles. And if I look back up here, I see that there is 1 mile is worth 1,760 yards. 1 mile is worth 1,760 of the yards. And then we need to convert the 10,560, that's yards, so I put it on the top row with yards. And here comes the peanut. So I have 1 times 10,560. And then I divide that by what is not in the peanut. Do it the same way every time. Don't be lazy. And then when the time comes, you'll know what you're doing. And that is 6 when I divide it. So in that one game, she ran 6 miles. Number 9. Safety rules at a distribution warehouse prohibit stacks of boxes higher than 5 feet 10 inches. That's the limit. Jamie stacks boxes that are each 14 inches tall. How many boxes can he use for each stack? So let me show you what this one's about. Here is a box that Jamie's stacking, and this box is 14 inches tall. So he's going to come along with another box, and he's going to stack it right on top of that box. What we want to know is how many boxes can he fit in there if this is the limit. If he goes above that line with the boxes, he's going to get in trouble. So we're trying, or Jamie's trying to figure out how many of those boxes can he stack up there. Well, the first thing that jumps out at me is that 5 feet. I really, really want that to be in inches, because if you notice, this is in inches and these are in inches. So I want to get everything in terms of inches. So let's go ahead and do the conversion. I'm going to say 5 feet. That's 5 times 12 inches per foot. That is 60. And 60 plus 10 means that the maximum here is 70 inches. And then I'm going to divide 70 inches by the height of a box. So 70 divided by 14 is 5. That means that the most he can stack draw it, guys. That will help you visualize what you're doing. And this is probably not going to work. Yes, it will. So in order to reach that 70 inches, he can get 5 boxes in there. Just start drawing. If you're not sure how to solve a problem, if you're not sure how to organize the problem, start drawing it, and that will help you get the idea of what you're doing. If you don't know if you're building up or breaking down, draw, and that will help. That's why you have scrap paper. Okay, number 9. That was number 9. I'm sorry, number 10. Adult Boykin Spaniels. I'm having issues with my pen here. I'm not sure what's... Oh, I do. The nib is loose. Adult Boykin Spaniels typically weigh 28 pounds. Zoe weighs 96 ounces as a puppy. How many more? That means subtract. How many more ounces will Zoe gain to reach the typical adult weight? Well, to help you visualize this one, I'm going to say that it represents an adult puppy, an adult dog. If I could draw, I would draw you a dog, but I can't. So this is the adult. And the adult weighs 28 pounds. And then here is a puppy that's growing into being an adult. Right now, that puppy is 96 ounces. So what we're looking for is this amount. How much more does Zoe have to gain before she reaches that full weight? So that helps visualize what's going on here. Here's what Zoe is now. So how much more does she have to gain to fill that space? So we need to convert the 98, the 28, guys. I am so sorry. I'm so sleepy. It's so early and I shouldn't do this early. We want to convert that to ounces. 28 pounds, there are 16 ounces in a pound. So let's multiply that on our calculator. As an adult, Zoe will weigh 448 ounces. Right now, Zoe weighs 96. So 448 minus the 96 is going to give me 352. So that means that this space here is 352 ounces. Okay, number 11. Jerry delivers bottled water. Each case of water weighs 40 pounds. His trailer has a maximum weight capacity of 3 tons. And Jerry loads 185 cases on the trailer. Part A. How many pounds is the trailer over the maximum weight capacity? So I'm going to start here by breaking down what I know. We know that this is a trailer that Jerry has. Pretend that that's a trailer. Last time it was Zoe, but it doesn't matter. It just represents an image in my mind. The trailer has a capacity of 3 tons. 3 tons times 2,000 pounds, that's 6,000 pounds that the trailer can hold. Now, we have another type of box. We have the case of water. And the water weighs 40 pounds. And Jerry has 185 of those cases. So let's do 185 times 40. And that is 7,400 pounds. Because this was 40 pounds. Okay, so we have our two numbers. The water weighs 7,400 pounds. The trailer is 3 tons, which is the same as 6,000 pounds capacity. So if you subtract the difference, he is 1,400 pounds over the limit. Part B. How many cases of water does Jerry need to unload, that's breaking down, so the trailer is not over its maximum capacity? So I'm going to say 1,400, that's the overload, divided by, remember these cases are 40 pounds. 1,400 is pounds. 40 is pounds. Those have to match, guys, or this won't work. So 1,400 divided by 40 is 35. So if he removes 35 cases, he will be okay. Number 12. A billboard sign is 16 yards long and 23 feet wide. Which sentence is true? Well, the first thing I'm going to do is draw myself a picture. And it is 16 feet long. Actually, and 21, no, I'm getting it all mixed up. It is 16 yards long. And 21 feet wide. And right there's the problem. I have yards and feet in the same picture. I need to get it to be all feet or all yards. I'm going to go to all yards, and here's why. Look at your question choices. Everything is in yards. So the 16 is already in yards. I need to convert the 21. Now I know that there are 3 feet in a yard. So 21 divided by 3 is going to give me 7 yards. So those are the numbers that I want to use. The billboard is 5 yards longer. That's subtraction. So if I do 7 from 16, that is 9 yards. So this is not true, this statement. The billboard is 5 yards wider than it is long. Again, 16 minus 7 is 9, not 5. The billboard is 9 yards longer than it is wide. Be careful. The numbers match up, but look at D. The billboard is 9 yards wider than it is long. The numbers also match up in this one. So I can eliminate A and B because the answer to that subtraction problem is 9, not 5. The question is, the 16 is the length. The 7 is the width. The 16 is the length. The 7 is the width. So which of these is worded correctly? We've got the math. We just have to figure out the wording. And the length is longer than the width, so this is C. The 9 that we found is on the length side. I don't like that question. To me, that's a trick question. We're focused on the 9, which is good. That's the math part. But you also have to read and make sure that the words are right too. And I'm okay with that. I just think that question's tricky. But it doesn't matter what I think. The test is going to write the questions as they see fit. So we have to be able to read them. All right, number 13. Ellen mixes 1 gallon-sized bag of grapes, 2 quart-sized bags of apples, and 6 pints of cranberries together, so this is building up, to make fruit salad. Each serving is 2 cups. How many servings of fruit salad can Ellen make? So the first thing I'm going to do is draw my bags of stuff. Okay, I'm going to leave that. All right, this is the grapes. And the grapes are in a gallon. Then she's got some quarts. That would be smaller than the grapes, but that's okay. These are apples. And that's 2 quarts. And then she has some cranberries. Again, the size of the bags, don't pay any attention to that. Or the shape. It's horrible. This is 6 pints. Okay, right there I have a problem because I have mixed units. I have gallon, quarts, and pints. They have to be the same. Each serving, so let's draw another box. Each serving is 2 cups. So I want to convert all of these into cups so that they'll match this one. Okay, I know that a gallon is 16 cups. That's exactly the same amount. I know that quarts, each quart has 4 cups, and I have 2 of them, so that is 8 cups in the quart. And then in the cranberries, I know that a pint has 2 cups, and I have 6 pints, so that's going to be 12 cups. And I need to build up my salad. I'm going to build up the fruit salad. We're going to take 16 plus 8, that's 24, plus 12, that's 36 cups of fruit salad. And then I'm going to break down my salad by 2 cup servings and get 18. Answer is A. So that horrible picture did its job. It helped me visualize what I'm doing. And that's what you're being tested on, guys and gals. It's not about the math, really. It's about the thinking that gets you to the math. Number 14. Each ream, a ream is a package of paper, is 3 inches thick. How many reams of paper does it take to make a stack that is 1 yard high? 3 inches, 1 yard. So here is a package of paper. It's 3 inches tall. And I want to stack those. Let's just get the idea. I'm not going to draw all these. I want to know how many of those it takes to be 1 yard tall. So we're looking at 1 yard here. So how many of those boxes does it take to equal that 1 yard height? So let's convert the yard to inches. 1 yard is the same as 36 inches. And 36 inches divided by 3 inches is 12. So I need 12 boxes to stack up here to make that yard high. 12 reams, and I should have said reams, not boxes. I don't know where I got boxes. I just make stuff up. It's not boxes, it's reams. Okay. So number 14 is B. Number 15. A practice track is 1/10 of a mile long. Jason runs 13 laps each afternoon. How many yards does Jason run in 1 day? So we have a track that is 1/10 of a mile. He goes around it 13 times, and we want to know how many yards that would be. So this time, I'm going to make an oval for my track, and it is 1/10 of a mile around that oval. So if he starts here, and he goes around and he comes back to that point, that's 1/10 of a mile. And he does that 13 times. So if you're using the Casio calculator, put this in as a fraction. 1 ABC 10 times 13. And you will get 1 3/10. Okay, that is 1 3/10 miles, because this unit is in miles. This unit will be in miles. Now we have to convert. I'm going to use a proportion on this one. We are comparing yards to miles, and you may be thinking, where's she getting yards? It's coming from right here. How many yards does Jason run? And I know that the conversion for yards and miles, let me just look back, it's 1760. 1 mile equals 1,760 yards, and that's what you want to use right here. 1,760 of the yards is equal to 1 mile, and we have 1 3/10 that Jason runs. So again, using your Casio, put that in as a mixed number, times 1760. So I have 1 3/10 times 1760. That is 2288. And then you divide that by 1, you are still going to get 2288. So he is running 2,288 yards every day. Number 15 is B. Number 16. Madeline has 4 books in her backpack. 2 books weigh 1 pound 8 ounces each. A third book weighs 1 pound 2 ounces. And the last book weighs 22 ounces. Which 2 answers represent the total weight of the books in Madeline's bag? Well, you know what I'm going to do. And I'm going to make 4 of them. And I'm not worried about scale. Don't worry if one's bigger or smaller. Just draw 4 of them. Don't even think about what they look like. We just want these to represent the books that she has in her backpack. 2 of the books weigh 1 pound 8 ounces. So 2 of them are identical, at least in weight. A third book weighs 1 pound and 2 ounces. And the last book weighs 22 ounces. So just looking at that, and we want a total that's building up. So we're going to add all of those. I can see that we have 3 pounds. And then 8 and 8 plus 2 plus 22 is 40 ounces. So I'm going to go ahead and convert that 40 ounces just because it's huge. I know that 16 ounces would be a pound. So 32 ounces would be 2 pounds. And then we would have 8 ounces left over because 40 minus 32 would leave us with 8 ounces left. So one way that I could say this is 3 plus 2. That's a total of 5 pounds with that 8 ounces left. So let's see if that is one of the choices. And there it is, C, 5 pounds, 8 ounces. That's how I would leave my answer. But they want us to find a second one. And all we can do with the second one is convert it all to ounces. So let's look here. 5 times 16. Remember, these are not fluid ounces. They are weight. That is 80 ounces. And 80 plus 8 is 88 ounces. So here are the 2 answers. C and E for number 16. They're saying exactly the same amount. It's just that one of them has pounds and one of them doesn't. Number 17. A shelf hangs on a wall at a height of 6 feet 4 inches. The highest point that Cindy can reach is 71 inches from the floor. How far out of Cindy's reach is the shelf? So here is a shelf that is hanging on the wall. And that shelf is at a height of 6 feet 4 inches. And then here's Cindy. We'll just make a line for Cindy. Cindy's reach is 71 inches. We're looking for this distance. Whoops, sorry. We want to know what that dimension is right there. How far out of her reach is the shelf? So I drew that, and I'm belaboring this to help you see that this is a subtraction problem. You're looking for the difference in those two heights. But I do need to convert everything to inches. So I'm going to take this 6 feet, that's 6 times 12, that is 72, plus the 4 inches there gives me 76 inches. Cindy can reach 71, so 76 minus 71 means that the shelf is only 5 inches out of her reach. Not a lot at all. So the answer to number 17 is B. Number 18. To build a fence, Winston installs a fence post every 8 yards. After the first post, he installs 25 more. That's building up. Makes sense because he's building a fence. How long is the fence Winston builds? So this is either addition or multiplication. But let me draw you a picture of what Winston's doing. There's a fence post, the first one, and then he's going to put 25 more fence posts, and I am not going to do that. I'm going to put 4, and then you'll just have to picture the rest in your mind. But there are the fence posts, and then Winston, is going to come over here and put fencing on those posts to keep his cattle in or whatever he's fencing in. So what they're telling me is that these lines between the posts are 8 yards long. So this one's 8 yards, this one's 8 yards, and this is going to go on 25 times. So 25 times 8 yards would give me my answer. Except my answer is not in terms of yards. My answers are in terms of feet. So let's go ahead and make the conversion right here. 8 yards, that's 8 times 3, because there are 3 feet in a yard. This is a distance of 8 yards, which you could also call 24 feet. So this is 24 feet, 24 feet, and so on. So I'm going to do 24 feet times 25 times that he does that, and see what I come up with. 600, and feet went into this problem, so feet come out of this problem. I'm liking answer C. Winston is building a fence that is 600 feet long. And finally, number 19. Abby fills a 16-ounce water flask. No, flask is just a water container, usually metal. Flasks are metal. You sometimes keep alcohol in flasks if you drink alcohol. From a bottle refill station that holds 5 gallons of water. So she puts a 16-ounce water flask full from the source that holds 5 gallons. How many times can Abby fill the water flask before the station is empty? So here's the station. I have one of these right outside my door at work. This is an awesome thing. They have 5 gallons of water in the station. And then Abby comes along with a little 16-ounce bottle of water and fills it up. So if Abby is the only person using that water station, how many times can she refill her bottle? In other words, this is the wonderful thing about technology. How many of those will it take to empty that station? What am I doing here? Am I building up or am I breaking down? Be careful. I'm breaking down. I'm taking the 5 gallons and I'm breaking it down by 16. And I don't know how many times that can happen. Let me show you something here. 16, I know what the bottle holds, times some unknown number of times equals, and here we have another problem, because the 16 is in ounces, the gallons can't mix with that. So let's multiply. I know that there are 16 cups in a gallon, and that each cup holds 8 fluid ounces. So 16 times 8 is 128 ounces, and we have 5 of those. We have 5 gallons. So we're looking at a tank that holds 640 ounces. So we want it to equal 640. Because remember, these have to match. So I'm looking for how many times I can fill that bottle. Now I could check all 4 of those answers and see which one fits. That will work. Or you can set it up as an algebra problem. 16 times unknown number of times is 640. Divide both sides by 16. So the number of times is, I believe it's 40, but let's be sure. 40. She could fill her water flask 40 times from that station. Okay, I liked this lesson. I like drawing the pictures and looking at different ways of thinking about problems. In the next lesson, we're going to be looking at metric measurement units. So for those of you who have been waiting on the metric system, it is coming very soon. I'll see you next for the lesson about the metric system. We'll learn the prefixes and what they mean, and then we'll do some practice with those. Remember to contact your instructor if you need more help. And I will see you soon for another video. I hope you have a great day. Bye-bye.